Hello and welcome to the statistics practice work sample walkthrough. For this work sample, we're looking at, it says statistics, but it's definitely more of a probability problem, and that's okay. So, first of all, I just want to read through this. It's about marbles. So, Bobby has a bag containing 75 marbles. The marbles are red, white, blue, green, and yellow. Okay. And I'm going to, for ease of reference right now, I'm going to tell you that we are looking at those letters, meaning those different colors. Okay, if I ever just use a letter, which I probably shouldn't without somewhere defining that R means red, even though it's pretty self-explanatory, somewhere you should define that like you're defining variables. Okay, if you're going to use those abbreviations other than writing out the colors. Okay. The probability of pulling a red marble out of the bag is 2 out of 10. The probability of pulling a white marble is 1 out of 3. The probability of pulling a blue marble is 8%. And there are 3 more yellow marbles than green marbles in the bag. Okay, and that would actually give us, that talks about every single color, so we would know how many of each type of marble are in the bag. Then, so that's all setting up the problem. That's showing you what's in the bag. Okay, and then here's the only question of this work sample, and I'm going to sort of highlight it in a different color. If Bobby pulls a green marble out of the bag and sets it aside, what's the probability that the next marble to be pulled out will be yellow? Okay, so that's really the question of, and there's really 2 things happening there. First of all, we're pulling a green marble out, setting it aside, and then we're asking the question, what's the probability of the next marble being yellow? So let's go ahead and look at a basic strategy for this work sample. So strategy. Really, the first thing I need to do is find what's in the bag. And for that, I really want to know, how many of each type of marble are in this bag. Okay, how many red, how many white, how many blue, green, and yellow are in this bag, and very detailed as to how many of each. Okay, and I'm going to use my probability rules and the information that I'm given to figure that out. But that's really your first step. Your second step is simply to then go to the problem and say, okay, we're pulling out a green marble. So pull a green. And really, at that point, you could say, now what's in the bag? Because really, you have a new bag of marbles now. And, there it was 75 to start, and now it would be 74 because you've taken one out. So now it's in the bag, and then find the probability of a yellow. Okay, so the probability of pulling a yellow would be how you actually find your answer, and that would be your final answer. Excuse me. Let's go ahead and look sort of one step at a time on how I solved it. Again, looking at statistics and probability, I think that it can be easy. It can be more common sense type problem, but you do have to have some skills and understand what's going on. Okay, and it does take a little bit of work in order to gain those skills. So not is it only what you learned. Well, I learned about probability back in 6th grade. Okay, this will take into account some new information that you've learned. Okay, so let's look at how I did it, and we'll take this sort of one step at a time just to get it out and just to keep it somewhat simple. So to find the probability that the next marble will be yellow, I need to do the following, and that's sort of what I just talked about. Determine the original makeup of the marbles, remove one green, and then determine the probability of a yellow. Okay, and that's what I just said was our strategy. But it's never bad to formalize your strategy in a work sample. It's sort of like, you're telling them what you're going to tell them, and then you tell them, and then you tell them what you told them. Okay, I know, confusing, right? Teacher talk, I'll tell you what. So let's just look at this first mess of stuff here, and sort of tough to do, but okay. I just want to look at this little table here, and this is kind of the best way that I've found to sort of describe what's in the bag. I'm looking at the marble, the probability, and the number of those that are in the bag. Okay, and I just listed all the colors. That's what you should probably do first. And then let's take the information from the problem. Okay, it tells me that 2 out of 10 will be red, 1 out of 3 will be white, and blue is 8%. So let's look over here. It says to find the number in the bag, I need to multiply the probability by the 75 original marbles that are in that bag. And that's how you figure out the number of anything when you know the probability of getting it. Okay. If I look at 2 out of 10, I want to turn all these things into percents. Okay. 2 out of 10 means 2 over 10. Okay. If I turn that into a percent, or I could leave it as a fraction, it just, what do you like multiplying by? Do you like multiplying by fractions or by decimals? Either one. But 2 out of 10 is 0.2, okay, which is the same as 20%. So that's kind of the important part there. I'm taking that 75, multiply it by 0.2, and that's going to give me 15. Okay. For the white marbles, it's 1 out of 3. I say it means 33.3 repeating percent. That's because it's 1 out of 3, or 1/3. Okay, same thing. You could turn it into a decimal, and thankfully turning it into that decimal and multiplying it by 75 gives us a whole number. Otherwise, that decimal might not be the best way to go. You can multiply by fractions too. You could have said 75 times 1/3. It would have been just fine. The blue makes it pretty easy. It tells us 8%. Remember, 8% is 0.08, and multiply 75 by 0.08, and you get 6. Okay, so at this point, we really just know this piece right here, and I'm looking at the table right now. I know that there's 15, 25, and 6 marbles out of my red, white, and blue. Okay, my green and yellow, and this part takes a little kind of the rest of this part of the page here. If I look at my green and yellow, there are 46 other marbles, and that's what I did here is I totaled this number up and got 46. So there's 46 of those. That means there's 29 green and yellow combined. Okay, 75 minus 46 would give me that 29. Okay, and once you know that, you could kind of guess and check your way if you wanted to do that. What I did is I set up an equation where I let green be x, and it said that there were 3 more yellow than green. So yellow would be the number of green plus 3, or x plus 3. Okay. And so that tells me that green and yellow equals 29. Green plus yellow is 29. Green is x, yellow is x plus 3 equals 29. I'm solving an equation here. Okay. Again, you can assume that people know how to do that. So I get 13 for the green, and I just say 16 yellow there. If you wanted to, plug that back into here and show that 13 plus 3 is 16, that wouldn't be a bad idea as well. Okay, but that's really the biggest part of this problem. I'd say it's one of the hardest parts of this problem is actually figuring out what this initial bag of marbles looks like. Okay, but it looks like 15, 25, 6, 13, and 16. Okay. Then I take 1 green out. Now we're on to step 2. Remove 1 green. What does the bag look like now? Well, still 15, 25, 6. The green goes down by 1, but everything else stays the same. Okay. I know that there's now 74 marbles. 16 of them are yellow. The way that you figure out probability is you look at the number of winning possibilities. Well, for us to win, we would have to pull a yellow over the total number. Okay, so 16 over 74, I get 0.216 repeating. And then, so that's sort of where I found my answer. And then make sure you frame that in the verbiage of the problem. The probability of pulling a yellow marble after pulling a green is 21.62%. Okay, I turned it back into a percent by moving that decimal over 2 spots. Okay, now that's kind of the first run through the problem there. The reflection, I totally look at an abridged version of the original write-up. You know, I don't want to write as much, but I want to make sure that I hit everything. Okay, so let's look here. I'm talking about the original makeup of the bag, and I went into a little more detail here. I turned those into percents right here, and I also said that the number in the bag is the 75 times the percent. Okay, sort of like a Excel worksheet here. So 2 out of 10 is 20%. 75 times 0.2 is 15. So same stuff there. And then again, I go into my green and yellow, but I use green and yellow in words as opposed to coming up with variables, and it works out the same. It works out just fine. Okay, so green plus yellow is 29. Green plus 3 is 29, and so that's 2 greens, or 2 times the green, plus 3 is 29, subtract 3, divide by 2, green is 13. And so you can see my equations there that weren't very much fun because of the fact that I I had to write out green and yellow. That's not a whole lot of fun. And then here I'm taking out one of those greens, saying what's in the bag now, showing the total, and I actually found, for some reason, probably a math nerd spark in me, found the probability of pulling any other color of marble. But notice that I'm showing what I'm doing. I'm saying the number in the bag divided by the total, so 15 out of 74, and all the way down. And then again, I say the probability of the second marble being yellow after green is pulled is 21.62%. So, you know, there are parts of this that are needed. There are parts that maybe aren't. I would say that this is a part that you could lose where you're finding the probability of all of them. But it's somewhat nice to know, and especially, you know, when I did it, I ended up adding all these back up and got really close to 100%. I was off because of the rounding, obviously, but it was, you know, 99 point something percent. So let's look at some potential pitfalls that students have in this type of work sample. Honestly, there aren't a lot of people that have tried probability work samples, but some places where I can see people at least having a hard time is definitely the green and yellow. Knowing that you need to find this number to figure out what the green and yellow add up to, being 29. That's one place where students can sort of fail. And then I would also say sort of the explanation on how you got those. I mean, I would talk about, you know, this part's very important in all of these. 1 out of 3 means that percentage, and saying that you're multiplying the probability by 75 is a very important step. And I mean, I have to think that there would be some hiccups here in finding the green and yellows. That's one of the harder parts of this problem. That's what really makes it a difficult problem, because you know, one is based on the other. After that, once you find the original distribution of the bag, how many of what color are in that bag, I think it's pretty easy. You take one green out, and you're just dividing your yellows by your total number of marbles. Okay, that part is pretty easy. That's why there's a lot more work up here than down here. But it is one reason that I like probability and think that people should try it as well. So, that being said, I really want you to think about, you know, possibly trying a statistics or probability problem. I think it can be a work sample that's frequently overlooked, but very doable. Let me know if I can help you, and we'll see you out there.